In this tutorial, we'll demonstrate how to create a parametric surface in Gizmo. A parametric surface is defined as by a three-layer 3D wave. In this example, we wrote some code that will generate such a wave. The code basically takes the number of points in the x and y direction, creates a wave called myData, and then fills the wave so that we have an index in x, an index in y, and 0 in z. So this is going to give us a flat surface if it works correctly. So now we'll execute the code, make data 1, we'll ask for 50 points by 50 points, and that created for us a wave called myData. To display that as a parametric surface, we go to Windows menu, New, 3D Plots, and choose Other. There is no entry here on the menu for parametric surface. This gives us a blank Gizmo window and blank Gizmo info. From the Gizmo info window, we'll go to the object list and choose Append New Object, and here we'll choose Surface. In the Surface dialog, the first thing that we do is we change the source type from matrix wave to parametric wave. When we did that, this automatically picked up the wave that we have, myData, because it's the only suitable wave in the current data folder. The other change that I want to make is I want to draw grid lines, and I want to choose a constant color here that is gray. And I'll set that to OK. At this point, as you can see, we have a surface object here, but nothing is drawn because there is nothing on the display list. So I'll drag surface 0 to the display list and drop it there. And now I have a flat surface displayed in Gizmo. I'm going to right-click in the Gizmo window and choose Show Axis Q just to provide myself better orientation. OK, so at this point, let's change the data so that it looks a little bit more interesting. And to do that, I modified the original function a little bit, added a few more variables. I'm going to scan in angle 2 pi in the x direction, pi in the y direction. And in this, I'm going to leave the z value still flat. So if I execute this, make data 2 with 50 points and 50 points, what I got here is a disk with a gap in it. Now the reason for the gap is simply because the differential angle in the x direction does not give us sufficient coverage. So we subtract 1 here when we compute the differential angle, and when we re-execute make data 2, it closes the gap as we would expect. Okay, so now that we have a disk, let's make it even more interesting than this. So we'll look at the third version of the function, and here we're going to basically do a calculation that uses a spherical coordinate system. So in here we're going to calculate the x and the y going from a radius in a spherical coordinate system, and then we're going to set the x and the y and the z as follows. So when we execute this command, make data 3, 50, 50, we get a nice cone. Now, a cone is still the type of object that can be generated without using a parametric surface. But it is one step in the direction of the final goal of this demonstration. So to go one step further, I'm going to edit this function one more time, and I'm going to reset the z value to be 1 minus the square root of the x and the square root of the y component, and it's multiplied in the front by the sign, and the sign will alternate depending on the angle theta. When I re-execute the command one more time, I get a sphere with some problems in the vertical direction. So to handle that, we go back to the code and we subtract 1 from the theta differential. It has exactly the same effect as the gap that we saw in the disk earlier. Having executed that, I got a parametric surface of a sphere, and you can see that this is a nice closed sphere that you couldn't describe by a regular function or a regular surface. This concludes this tutorial.